Hi friends, welcome back to the series of videos on plastic product design consideration. So in today's video, we are discussing one of the important factor, that is rib. Ribs are basically used to provide a strength to a given part. So suppose if you want to increase a strength of a given plastic part, we can also go for increasing a wall thickness, but it will again results into increasing material cost as well as weight of a given plastic part will increase. So instead of increasing a wall thickness, we can provide a sufficient amount of ribs in that location. So if we provide a rib, then where the rib joins to the wall thickness, there will be increase in a thickness. So let's understand this phenomena by this graphical representation. So in this image we can observe that the rib is joining to a wall thickness at this location. So we can measure the rib root thickness at this location. So it will be more than the nominal thickness or a wall thickness of a given plastic part. So again, increasing thickness at this location will cause a sinking mark or a sink mark at this location, which is not desirable. So we can have a multiple options to avoid the sink mark at this location. So one of that option will be to provide a groove or a dent at this location like this one, which is opposite to the rib location. Okay, so we can avoid a sink mark at this location to have a uniform thickness. Also we can go for a thin cross section rib also, but for that we need to provide a rib which is deeper to have a sufficient rigidity, and which will again causes failure of a rib due to buckling load. So we can't use a thinner rib. So also it will cause a filling problem for a plastic melt into that gap, and also machining problem. Also due to increase in a injection pressure, this rib surface might get grip to the cavity surface also. So we cannot use a thin cross section rib. So there is a standard procedure to provide a thickness of a rib. So let's understand this method by a simple example. So suppose I am having thickness of this wall as a suppose 100 mm. So for simplified calculation I am using this value. So if I am having thickness of a wall as a 100 mm, then standard procedure will be to provide a thickness of a rib is 65% of a given wall thickness. So my thickness of a rib will be 65 mm, and the fillet at this location, that is rib fillet, will be 40% of a wall thickness. That means it comes to a value of 40 mm. Then increase in thickness at this location will be 23% more than thickness of this wall. That means thickness at this location will be somewhat around 123 mm. Okay, so it is desirable to have a value which is less than 25% at this location. So increasing thickness should be less than 25%. If you use rib thickness equal to wall thickness, then in that case the increasing thickness at this location will be somewhat around 75%. That means overall thickness at this location will be 175 mm, which is not satisfying this criteria. So most commonly thickness of a rib is taken between 50 to 70% of a given wall thickness, and also fillet radius will be between 40 to 60 mm. Okay, so one more thing is that in a design of a rib is that ribs are provided in the direction of drop. So in order to simplify the ejection of a rib, we can provide a taper to a given rib. So if you increase the taper angle of a rib, then it might form a thinner section at tip, which will again causes a problem for a injection molding. So there are parameters like rib depth should be 5 times the rib thickness. That means we can use the thickness of we can use depth of a rib which is equal to 5 times the rib thickness. And one more parameter is that ribs should not be closer to each other. So the distance between the rib should be 2 or 3 times the rib thickness. So these are all things we need to consider while designing a rib for a given plastic part. So actual example will be, so there is a rib provided at this location in order to strengthen given plastic part at this location, because stress concentration is happening at this location because of loading condition. Also, in case of this tool, there are ribs are provided in a groups in order to increase the strength of a given plastic part, because loading condition will be in this direction. So what we have learned from today's video is that ribs are provided whenever we need to increase a strength of a given plastic part. Rib thickness should be between 50 to 70% of a given wall thickness, and rib fillet radius will be between 40 to 60% of a wall thickness. Then rib should be provided in a tapered manner. Then depth of a rib should not be more than 5 times the rib thickness. So these are the considerations we need to consider while designing any plastic part. Thank you, friends.